Any other questions? Okay, well, thank you very much.
Thank you.
We'll proceed to the second presentation.
The second and the third presentations will be made by Srđana KOLAKOVIC from Faculty of Technical Sciences of Novi University, Serbia. Ms. KOLAKOVIC will be making a presentation on basic data required for wastewater treatment plant design, and the second presentation is dedicated to current status in wastewater treatment in Serbia.
Thank you very much. Good morning to everybody. The first topic is basic data required for wastewater treatment plant design. The content of this presentation is introduction, determination of hydraulic capacity, determination of wastewater composition and load, and at the end, conclusions. Wastewater collection, treatment, and disposal facilities need to be designed in the way that they can handle the specific hydraulic and pollution loads, not only at the present time, but also for 20 or more years after they are constructed. And to properly size and equip such facilities, it is very important that we consider all the population, not only today, but in the whole project life of the plant. Also the flow of the wastewater and the stormwater, of course, that will be diverted into the system from that population. And we also need quantities and types of the pollutions which are contained in that wastewater. As for the hydraulic capacity, there are three ways in which that can be quantified. The first one is by measuring the water supply. We can calculate the generated amounts of wastewater from the water supply from domestic, industrial, and commercial uses. This method is not very favored since it is difficult to make estimates of the water, of the amounts of the water which are supplied from the non-alternative sources, such as private vendors, rainwater harvesting, springs, and so on. The other way to calculate the hydraulic capacity is by measuring the wastewater flows. This method measures only the metered wastewater flows from the sewered communities, and it also has its flaws because it doesn't take into consideration the amount of water from households which use cesspits and septic tanks, and these amounts of wastewater also needs to be estimated and accounted. The third way to measure the hydraulic capacity of the wastewater treatment plant is by measuring the water consumption. This method quantifies the amount of wastewater generated from domestic, commercial, and industrial water uses based on the average per capita water consumption. And this technique is good because it allows easy calculation, and it also takes into consideration the water saving efforts. But we should still have some data about the flows of the wastewater, so the best way is to combine these two measurements. In European countries, the water consumption on household level ranges between 80 liters per person a day, which is the lowest, and we see that it is in Lithuania, and 250 liters per person a day in Spain. On this graph, unfortunately, we don't see Serbia and we don't see Greece too, but on the next slide I will tell about the consumption of the water in Serbia. The average water consumption in Serbia is estimated as approximately 320 liters per capita per day, where 400 is for the consumption of the urban population and 250 is for the rural areas. But these measurements we cannot take seriously because of the poor water production measurement, and it's a fact that the water consumption in Serbia is not this big. Also, the big problem is that losses from the systems of drinking water in some areas, due to the fact that the distribution systems are very old, can sometimes be even 60%. It's a fact also that in Serbia the price for the water is smaller than in industrial European countries. it goes only for the drinking water is 0.1, 0.3 euros per cubic meter for household use, and for industrial use is a little higher. But also, if we take into consideration the price together with the sewage and treatment price, it goes up to 0.5 or 0.75 euros, which is still much less than in industrial European countries. This is the example of Novi Sad water distribution system, which shows us that we cannot take the consumption, the amount of the consumed water from the distribution system and divide it with the total population, because we first need to make some kind of analysis. This example shows us that total amount of distributed water in liters per capita per day in Novi Sad was 340 liters, from which only 240 was registered consumption, 170 was consumption of inhabitants, 25 was the consumption of large industrial facilities, and 45 was public consumption. And this still leaves us with 100 liters per capita per day, which is unregistered consumption. And it is assumed that this is due to the losses in distribution system and also illegal connections to the distribution system. Domestic water consumption and so wastewater production typically depends on water supply service level, climate, and water availability. As for the water supply service, we can see that it varies in industrial regions, developing regions, and semi-arid regions. And it varies also in the order of the type of the water supply service. Here we can see the average wastewater flow, which is the biggest in industrial regions, while, of course, it's the smallest in semi-arid regions. Domestic peak design flow rates commonly used in various countries take into consideration also the commercial industrial peak flows. And of course, where it is appropriate, we need to take into consideration also the infiltration. In addition to municipal and industrial sources, which are the base component of the flow, we call it the dry weather flow. We also need to account the drainage of rainwater, the stormwater flow, which also contributes to the total wastewater flow to be treated at the wastewater treatment plant. The extent to which the stormwater will impact the hydraulic capacity of the wastewater treatment plant depends also by the collection system, as we know that combined systems usually carry much more stormwater to the wastewater treatment plant than the separate systems. This is not only the problem in the sense of the hydraulic capacity, but also we know that conventional systems work more efficiently when they have constant quantity and constant quality of the wastewater. The peaking factor, which is used to forecast the maximum peaking flow, is highly related to the number of consumers, the service areas, and the duration of the peak flow of a water distribution network. In this table, we can see some formulas which can be used to calculate the peaking factor, and it is based on the population and the water demand which is needed for 1,000 of people. Here we can use these formulas depending on the population limits, where we can see that the first formula is for the bigger populations, while the third formula is used for the smaller population rates. As for the wastewater composition and load, this composition of municipal wastewater can vary significantly from one location to another. And the main reasons for this is the consumption in households and infiltration and exfiltration during transport in the sewage system. But regarding to the wastewater that comes only from the pure municipal and urban sources is usually of pretty much constant composition. The different situation we have if the industry is also connected to the wastewater treatment plant, then we can have the influence of wastewater which varies significantly, and it depends on the type of the industry and the management of the industry. The contaminants transported by these wastewater flows determine in a large way biological capacity of the wastewater treatment plant, which is required to treat these pollutions. Person load also can vary considerably. The reasons for this variation is working place outside of the catchment, socioeconomic factors, lifestyle, type of household installation, level of facilities available for water and sanitation systems, and other reasons. In this table, we can see that the range of the variations of chemical oxygen demand is from 25 to 200, for biochemical oxygen demand 15 to 80, nitrogen 2 to 15, and phosphorus 1 to 3. While we also see that the person load in various countries differs, and as for the consumption of the water was the biggest in the United States, also the person load amount is the biggest in the United States. Conclusion, in order to select and size both collection and treatment facilities for planning period of the wastewater treatment plant, we need to know the wastewater flow and organic loading, and we need to determine them with large certainty. Dry weather flows, wet weather flows, infiltration and inflow are the factors which are most important to design of wastewater collection, treatment, and disposal facilities. We also need to know the variations of domestic water use and the daily volume per person. And each country should set the standards for the design of wastewater treatment plant according to the specific conditions which are in their country. Thank you for your attention.
Thank you for the presentations. If you have any questions, please go on. Please.
Do you have a standards to design wastewater treatment plants in Serbia?
We have some, let's say, guidelines which are used most commonly in the similar waste. They are based on the knowledge from the previous wastewater treatment plants that they are done, and yes, they are usually done on the same way. But there is a problem with the lack of data for the specific locations. But for the biggest treatment plants in the cities, it's usually done like that with the guidelines.
And what guidelines you used for design of a wastewater treatment plant? Your guys or another?
No, we were combining the knowledge on our own location and also the German guidelines for the, yeah. Welcome.
But you have a very small value for BOD.
Mm-hmm. There.
15.
BOD is, it was 50.
Come back to...
Yeah.
So.
BOD 15 to 80. Yeah, we usually
It's
consider.
very small, 15.
Yeah, this is by.
Generally speaking, is 60.
It's 60. Yeah, we use 60 in Serbia.
I don't
yeah.
know where this value is very
Small. Yeah, I agree.
Yeah, okay. Thank you.
Any other questions?
In addition to conventional pollutants such as BOD, COD, and so on, ammonia, there are a lot of other chemical compounds such as pharmaceuticals, other xenobiotics, illicit drugs, and so on. Will you take any care of this sort of chemicals for design?
We started some researches about the amount of these chemicals, especially in the river Danube, but we still don't have some treatment facilities which treat this water and which remove these chemicals from the waters.
So you don't take this into consideration?
No.
Thank you.
We have no other questions, then we can proceed with the second presentation.
Okay. The next topic is related to the things that we talked. It's current status in wastewater treatment in Serbia. As for the content, we have the situation in Serbia in the area of channeling and wastewater treatment, evaluation of financial resources needed to resolve this problematic, and of course at the end some conclusions. We all know that development of sanitary systems started primarily as health concern, not as an environmental problem. But as the society developed, it was necessary to start resolving also environmental issues. Today we have a lot of differences between the industrial and developing countries, and there is a certain standard which is used today and takes into consideration the large facilities large centralized facilities with big sewage collection systems. But in the last few years, there was some arguments, and it started to be resolved on some different ways, like taking smaller natural treatment facilities. Cost-benefit analysis can be mean of reaching sustainable system even in developing country. So it's very important to have some analysis about the cost that we can get and the products that we can get from the wastewater treatment facilities in order to have a sustainable system. I will tell you now about the main problems which are in Serbia in the area of channeling and wastewater treatment. They are degraded quality of water bodies. A big percent of the population is not connected to the sewage system. We have inadequate maintenance of the old sewage systems, lack of data in some areas about the population connectivity. We have the direct discharge of the untreated wastewaters even from the big cities into the water bodies. We have unawareness of the population about the environmental issues, and also unsatisfying analysis for the design of wastewater collection and treatment facilities. Regarding to the degraded quality of water bodies, this quality control of surface and underground water in Serbia is done in accordance with the regulation for systematic testing of water quality by the government of Republic of Serbia. We have 4 classes of the water bodies, which the 4th is the worst one. And devastating data is that 48% of 160 measuring profiles are in the 4th class, so the worst one. And many of the water bodies are even beyond any class. The situation with water quality is especially difficult where the recipients of wastewaters are used Danube-Tisa-Danube channels, and some parts of these channels represent even the worst parts in Europe regarding to the wastewater. As for the inorganic pollution, we have small number of big polluters like thermal power plants and chemical industry, and organic pollution comes from 40% comes from the big industrial polluters, mainly agricultural complexes, sugar, beer, and milk industries. The next problem is population which is not connected to the sewage system. Connection of the population to the sewage systems in big European cities is usually more than 95%, while in the main city of Serbia, Belgrade, it's 85%. But situation is even worse when it comes to the other parts of Serbia, like in the region of Vojvodina. The connectivity of the population to the sewage systems is 45%, and in central Serbia without Belgrade is only 37%. This takes us to the number that total percent of population in Serbia which is connected to the sewage system is 56%. This is worse when we look at the rural population and urban population, where it's obvious that rural population is in a very bad situation. It has only 9% of the connection, while in the cities the connection is 75%. This leads us to a number that only 16% of the population is connected to some kind of treatment of wastewater. Around 13% out of this is on the biological treatment, but it's a question of the efficiency of working of these treatment plants. The next problem is inadequate maintenance of the old sewage systems. Lack of investment and maintenance led to breakage of pipes and infiltration of polluted water to underground, which is also seen in the source for the water supply strand in Novi Sad, which had this problem with pollution. Most of the sewage network, including the one in the biggest cities, it's built earlier on the combined principle, where the municipal wastewater is collected together with rainwater and water from washing streets and other public areas, which I already said it is bad due to the constant change of quality and quantity of wastewaters. These are the pictures which were not taken so long time ago. It happens in the city of Novi Sad when it comes to the large storm water rain, and we literally have floods on the streets. There is the problem with the lack of data in some areas about the population connectivity. In some regions of Serbia, it is very hard to determine the old sewage networks and the number of households which are connected to these sewage networks. Also, direct discharge of the untreated wastewater, which is going directly to the water bodies, either from municipal or industrial facilities. And we also have untreated landfill leachate, drainage water from agriculture, and pollution from floodings and river navigations. All these pollutions goes directly to water recipients. Also, the big part of the settlements in rural areas, but also in the border of the cities, use still the water permeable septic tanks, and they influence groundwaters, but also minor surface bodies which are around those settlements. Industrial facilities usually release their wastewaters to municipal sewage without any previous treatment, or they release them directly to water bodies, as we know that the larger industrial facilities are always on the river banks. And this means that the regulations and the laws need to be different. Unawareness of the population about the environmental issues. It's also a big problem because the population is not aware of their actions and the causes that their actions do. We have also the problem with the inhabitants on the Lake Palić. This is the water which is very polluted in the Lake Palić, and it used to be a big touristical attraction. It still is, but for years it is prohibited to swim in this lake. And people who live by the coast of the Lake Palić still don't want to be connected to the sewage systems. Unsatisfying analysis for the design of wastewater collection treatment facilities. All these problems that I mentioned earlier lead to the lack of data, and as we know, the sewage and treatment system of wastewater treatment plants is a complex system which requires the data about the climate, geology, geography, and other data about the specific location. We also need the wastewater analysis and pilot plants to be able to provide a design for a sustainable system, because without this we have a huge problem with plants which are oversized, not working properly, have inadequate maintenance, or provide poor water quality, which of course costs money. Here in this table I left some of the treatment plants that are built in Serbia. The others you can see in the paper, but I left these ones just to show that all of them have some problems, like insufficient capacity, they are technically outdated, they have technical malfunction, they have problems with the industry who is discharging untreated wastewater in their sewage network, and they don't have enough efficiency. This is the evaluation of financial resources which is needed to resolve this problematic. The first graph is for the urban areas, where we can see that 160 is needed for the sewage network, while 220 euros per capita is needed for the wastewater treatment plants. And the next graph is for the rural area, where it's considered together 528 euros per capita for the sewage and treatment plants. This leads us to the calculation from the population census from 2011, where we have the needed economic fundings for the population in urban area. The difference between the number of the population is because from this number it is taken the population which is already on some kind of wastewater treatment, but it is considered that even the old sewage network needs to be repaired, so they are included in that point. And with all this, we can see that it would be necessary in the next 15 to 20 years to invest 3 billion euros in this problematic for wastewaters. Conclusions. In order to have a sustainable environment, Serbia needs to work on the issues regarding to this problematic, not only for the wastewaters, but also for the waste management. And the later we start to resolve the constant degradation, the harder it would be to find some solutions, especially if we expect larger industrial growth in the next period. And it's a fact that industrial facilities must not only treat their wastewaters before discharge, they also need to improve and to modernize their production processes because they need to make the pollution smaller, not only to treat it. Resolving the problems must include data collecting and pilot projects in order to prevent having inadequate solutions, which we have today, as I already showed you. Monitoring and efficient control is very important so the plant can function efficiently. And sometimes restoration and upgrading of facilities can be even bigger and more expensive problem. That is why we cannot allow ourselves to have solutions which are inadequate, unsustainable, or not giving proper results, neither to neglect the facilities that once worked properly. Thank you for the attention.
Thank you for a very good presentation. Do we have questions? Yes, please.
It was not clear to untreated wastewater to discharge
Okay.
to land in landfill leachate. I understand that this wastewater goes to landfill or land area by open channel, like river. I'm suspicious about the epidemiologic disease, odor, and other disasters.
No, the thing with the landfill leachate is that it's not treated. It comes collected and it goes directly to water bodies. We don't have a facility which is treating the leachate from the landfills of the municipal waste. We also have the problem with a lot of landfills which are not, how can I say, they are not ordered.
But big part of the Serbian population is untreated wastewater. Discharged to,
for example,
open channel. There is no faucetic. Huh?
Yeah, they have a lot of. Yeah, they have septic tanks, but they are not. They don't have the what. They are water permeable, so the water goes to the underground waters. They are not done.
Underground.
Yeah, by infiltration.
Thank you.
Welcome.
Thank you. More questions?
You didn't mention what was the effect of the war on the infrastructure as well as the water quality.
The effect of the war.
A few years ago.
Yeah, you think on the bombing or
yes.
the?
Yes.
Okay. Well, we have a lot of problems with it's considered that, for example, in the Danube, by Novi Sad, we had a lot of bombing, and a lot of all the bridges were destroyed at that time, and that material and also some parts of the bombs are still in the river of Danube on that locations.
And the oil refinery from oil.
Yeah, and the oil refinery was also bombed.
How about the infrastructure?
The
treatment plants, have they been affected?
The Novi Sad, for example, the city of Novi Sad and the Belgrade, they don't have treatment plants. They discharge the waters directly to Danube, so the facility, wasn't what to be affected. As to the treatment plant in the city of Subotica on the north, it wasn't affected by the bombing.
I have a question which is wrong. Oh, please.
Do you have a plan to comply with the European Union regulation?
Yeah, we are currently working on that plan. We have a lot of documents and guidelines which need to be done. We are also improving our legislation in the way of industrial discharge into the municipal sewage, but for all that needs a little more time and money, of course.
And are there wastewater treatment plants under rehabilitation program now?
Yeah, there is a rehabilitation program, but some of the wastewater treatment plants, unfortunately, are completely not usable. They need to be shut down and rebuilt. Yeah, rebuild the new ones.
Any other questions? My question is regarding, first of all, I noticed that the situation is pretty similar to what we have in my country, Armenia, when we have the connectivity to the sewage system in the urban areas is quite high, and in the rural areas it's close to zero.
Yeah.
And I guess we share this problem around the Black Sea, most of the countries. But my question, you mentioned that in your slide about this lake Palić, that there's some people who don't want to be connected to the sewage system, and this sounds strange to me.
Yeah. Well, because the Lake Palić is the recipient of the wastewater from the city of Subotica, which is next to the Palić village or settlement, and those wastewater are treated on the plant, and they are treated very successfully. That treatment plant has even the tertiary treatment, and it has very good results. But due to the constant degradation of the lake for many years behind, and on the lake of Palić, there are a lot of like summer houses, or how do I call them, which are built illegally near to the coast of the lake, and they are just discharging their wastewaters directly to the lake. Especially because the Lake Palić is separated on 4 parts. The 4th part is the last part, the most far from the treatment plant, but it's a touristical part, so the water quality there is the worst, and it's the water quality that you can see when you go to the lake.
So, but why wouldn't people want to be connected? Is it expensive?
They don't want to pay because they think, okay, why do I have to pay to be connected to the sewage system if I can just put my bucket out?
Thank you.
Welcome.